Okay, so I'm Allison Stiteler, and this is my presentation on chapters 1 through 6. And these are just the chapters that we covered in chapter 1 through 6. For chapter 1, I'm going to be focusing on the 7-layer OSI model, or the Open Systems Interconnection model. And it was developed by ISO, and it's used to help understand networking protocols. So the application layer describes the interface between two applications on separate computers. And the protocols used here are the HTTP, which we're familiar with, and the SNMP protocol, and that just monitors and gathers network traffic information. And with this layer, there's also payloads, which are data that is passed between applications or utility programs and the operating system. So next, the presentation layer is responsible for reformatting, compressing, and/or encrypting data in a way that the app on the receiving end can read. And an example of this is an email can be encrypted at this layer. And I just included a little diagram of this. And next, the session layer describes how data between applications is synced and recovered if the messages don't arrive intact. So an example of this is the Zoom app. It works with your operating system to establish and maintain a session. And an API is an application programming interface, and it's an access point into a software's available processes, such that a specific type of request will generate a particular response. And next we have the transport layer, and it transports application layer payloads, which we talked about, from one application to another. And it also has two main protocols similar to the application layer. It has the TCP and UDP, or the transmission control protocol, and the user datagram protocol. So TCP makes a connection with the end host, and it checks whether data is received, and it resends it if it wasn't. And it also takes large messages and divides it into what they call segments. And TCP is also connection oriented, whereas UDP, it doesn't guarantee delivery because it doesn't maintain a connection to check if the data was or wasn't received. And these large messages are divided into datagrams, which is different from segments in TCP. And it's also a connectionless protocol. Then next we have the network layer, also known as the internet layer, and this layer moves messages from one node to another until they reach the intended destination host. And an example of this is routers, and protocols used at this layer are the IP, or the Internet Protocol, which adds a network layer header to the message, and then it becomes a packet. And I included a diagram of this up here. And next is the data link layer, also known as the link layer. And this layer puts control information in a data link layer header at the end of the packet in a trailer, and this is called a frame. And also at this layer you have MAC addresses, or media access control addresses, and these are embedded on every network adapter on the globe. And to the right I have a diagram of explaining how MAC addresses work. And next you have the physical layer, which sends bits via a wired or wireless transmission. So this can be done through wavelengths, for example, Wi-Fi, voltage on a copper wire. For example, that would be Ethernet on a twisted pair, or it could also be through light, which could be Ethernet on fiber optic. And here you could see each of these, the coax, cord, Ethernet, Wi-Fi, and fiber optic. And from chapter 2, I'm going to be talking about asset management. And with asset management, you have to anticipate failure. So you have the mean time between failures, or the MTBF. And this is the average amount of time that will pass before the next failure is expected. And you also have the MTTR, the mean time to repair. And this is the amount of time required to repair the device. And you also have redundancy, which means if one part, service, or connection fails, the other takes over, and this eliminates a single point of failure, which you do not want to have. And then with this, you also have automatic failover, which is assuming the duties of a failed component. So with this, you want to you should have redundant NICs, power supplies, cooling fans, and processors. Then the system lifecycle, or the SLC, is a process of designing, implementing, and maintaining network components, which over here you could see it includes requirements in analysis, design, planning, development, and testing, implementation, documentation, and maintenance, and evaluation. And this chapter also included the configuration management, which is the process of efficiently, effectively, and securely handling system configurations to maintain a desired state. And configuration management included discovery, version control, monitoring, automation, and auditing. And then you have decommissioning, which is the process of removing a system from production. And you should document the configuration and status beforehand, before it's removed. And here you have the EOS, or end of support, which is when support for an older system is terminated. And you also have EOL, or end of life, which is when the product is no longer being sold or produced. And this may be the same date as the EOS, or it could be a date before the EOS. And chapter 3, I'll be talking about troubleshooting address problems. So first we have ping, or the packet internet grouper, and this just verifies that the TCP IP is installed, bound to the NIC, configured correctly, and is communicating with the network. And it does this through echo requests and echo replies, and it uses the ICMP, or Internet Control Message Protocol. And for Linux computers running IPv6, you want to use the ping6 command, and for Windows, you want to use ping-6. Then for IP commands, we have ipconfig for Windows, and this shows your current TCP IP addressing. And for a more complete summary of this information, you can use ipconfig-all. And then for Linux and Unix, you have the command IP, and it's just to view and manage your TCP IP settings. And you can also use the ifconfig command as well, and these require elevated privileges, so not everyone can perform these commands. Then hostname and NS lookup. Hostname for Windows, Unix, and Linux, this is the command that's the same for all of these operating systems, and it's just a basic command to display a device's host name. And then NS lookup, or name server lookup, allows the user to query the DNS database from any computer on a network. And you also have reverse DNS lookup, which is finding the host name of a device whose IP address you know. And then the dig command is the domain information grouper. It's available on Linux and Mac OS, and this command just provides more detailed information than NSLOOKUP, and it also pulls this information from more reliable sources. And this command is useful for querying DNS name servers for their information about the host address and other DNS records. And then for chapter 4, I'll be talking about encryption. So encryption is the last layer of defense against data theft, and its purpose is to keep information private. And encryption protocols use a cipher to scramble the data into a format that can only be read by deciphering or decrypting the data. And new encryption forms are being developed currently, but so are new ways of deciphering them. And an example of this is quantum computing. While it's not super available now and it's very expensive, it's not super problematic as of right now, but as it becomes more available, it could pose a risk. So there's two forms of key encryption. The first one is private key encryption, and it uses a single key that only the sender and the receiver know. And this is also known as symmetric encryption because the same key is used during the encryption and decryption. And an issue with this is possible key interception. And the second type of key encryption is public key encryption, and this uses a private key known only by the user and a public key to decrypt it, which is often mathematically related. Or you could also have a public key to encrypt it and a private key to decrypt it. And public key encryption ensures integrity and confidentiality, and it's also known as asymmetric encryption because you're using two different keys. And then for chapter 5, I'll cover some transmission basics. So some basic terms are frequency, which is typically measured in megahertz or gigahertz. And this is the number of times in a second that an electrical signal can change states. Bandwidth is the amount of data that could be theoretically transmitted in a given period of time. And throughput is a measure of how much data is actually transmitted during the given period of time. So this diagram kind of shows that in an easy to see way. Noise is something that distorts or degrades a signal, and there's two types of noise. EMI can come from power lines, motors, TVs, copiers, and then crosstalk is where a signal on one wire infringes on the adjacent wire signal. You have alien crosstalk, which occurs between two cables, near-end crosstalk or NEXT, and this occurs near the source. And far-end crosstalk occurs at the far end of the cable. And then attenuation and latency. Attenuation is the loss of a signal strength as it travels away from a source, but you can use a repeater to boost these signals and to prevent attenuation. And latency is the delay between the signal transmission and receipt, and it's determined by the length of the cable and the existence of other devices. And then for chapter 6, I'm going to be talking about troubleshooting Wi-Fi networks. Okay, so some tools for this are a spectrum analyzer, which is a device that can assess the quality of a wireless signal, and it scans a band of frequencies for signals and noise, and a spectrum analyzer is best to figure out where the interference is highest. And you also have a Wi-Fi analyzer, which you can see in the picture to the right. And this is a software that can evaluate Wi-Fi network availability, and it can also help to optimize your Wi-Fi settings and identify security threats. So if you have no Wi-Fi connection, a couple of reasons for this could be that your SSID is wrong, an encryption protocol mismatch, an incorrect password, or static channel utilization, or you could have a stalled AP association. And if you're having a slow connection, you could have insufficient wireless coverage, signal degradation or loss, interference, channel overlap, incorrect antenna type, or you could have problems with firmware updates.